So in this video, you are going to learn about two special right triangles. So there is something really special that happens when you have a 45, 45, 90 degree triangle. So one, it's isosceles, okay, and then something happens with the sides of the triangle. So Theorem 1, in a triangle whose angles measure 45, 45, and 90, the hypotenuse has a length equal to the product of, I should say product, not produce, of square root of 2 and the length of either of the leg. So what that means is if you know the legs, you tack on a square root of a 2 to find the hypotenuse. If you know the hypotenuse, you need to divide it by the square root of a 2 to find the two legs. Now, obviously, it's a whole lot easier if they give you the legs and you want to find the hypotenuse. It's a little bit harder the other way around. So let's look at some examples. So on number 1, I've got a 45, 45, 90 triangle, and I want to find A and I want to find B, okay? Well, I know A and 7 are going to be the same because it's an isosceles triangle and the angles opposite of 45 are the same. So I know A is a 7, okay? All right, now to find B, I just need to add a square root of a 2 to the end of it. So it would be 7 root 2. Yes, it is that simple. All right. On number 2, again, I got a 45, 45, 90 triangle. So my x and my y are going to be the same. Now, to find the sides, I need to get rid of the square root of a 2. So basically, x is 4 and y is 4. Okay? So if they give you square root of, hello. If they give you square root of a 2 for the hypotenuse, all you really have to do is ignore it to find the two legs. Okay? So obviously, these are the pretty easy problems, and they do get a little bit harder. So on number 3, again, I've got a 45, 45, 90 triangle, and they gave me the side length. Okay? So I know this side and this side are the same. So I know y is going to be 3 square root of 2 over 2. Now to find the x, that's going to be the hypotenuse, and I'm going to have to multiply by the square root of a 2. So I'm going to have 3 root 2 over 2, and I want to multiply by the square root of a 2. Okay? So I'm going to have a 2 in the denominator. Square root of a 2 times the square root of a 2 is a 2. Whoop. Well, it's actually 3 root 4, which I know the square root of 4 is a 2, so it's 3 times 2 over 2. 3 times 2 is 6, over 2 is 3. So x is going to be a 3. Trickier. All right, last tricky problem. So again, I have 45, 45, 90 triangle, so C and D are going to be the same, and they gave you the hypotenuse. But they did not put a nice little square root of 2 on the end, so I can't just figure out what C and D are. So again, to find the legs, you're going to have to do the hypotenuse divided by the square root of a 2. Now, we know from previous lessons that you cannot have a radical in the denominator. So I need to simplify by timesing by the square root of a 2 on the top and the bottom, which would give me a 2, and I'd be left with 16 root 2, and then simplify this, 16 divided by 2 is 8, so my answer is 8 root 2. So 8 root 2 goes here, and 8 root 2 goes there. Now to check if we're right, I know to go from the side to the hypotenuse, you can times by the square root of a 2. So let's double check that and times by the square root of a 2. Square root of 2 times square root of 2 is a 2. 8 times 2 is a 16, so it worked. Okay? So it's going to be really tricky if they give you a number for the hypotenuse that does not have the square root of a 2, because you're going to have to divide by the square root of a 2 and rationalize the denominator. Again, over here, if they give you a crazy funky side, to get from the side to the hypotenuse, you're going to have to multiply by the square root of a 2 and do some things like that. Okay? All right, but believe it or not, 45, 45, 90 triangles are not the hardest. You have 30, 60, 90 degree triangles, which get a little bit trickier, only because there are more angles. So Theorem 2 is in a triangle whose measures are 30, 60, 90, the hypotenuse has a length equal to twice the leg of the shorter side. So what that means is this is going to be 30 degrees because it's opposite of my short side. And so the 30-degree angle and the 90-degree angle are going to be double each other. Okay? So if you know the short side, that's probably the easiest. You got to double it to find the hypotenuse. Now the length of the longer side, which is down here, is the product of square root of 3 and the length of the shorter side. So basically you have to find the shorter side in all of these before you can do anything. Okay? Once you find the shorter side, you can find the longer side by timesing the square root of 3. Okay? Which is the trickiest part. So here's a little bit of a shortcut. If you know the short leg is going to be half of the hypotenuse. So if you know the hypotenuse divided by 2, that'll give you the short leg. If you know the long leg and you're trying to find the short leg, you have to get rid of the square root of a 3 by dividing by the square root of 3. Now, if you're looking for the hypotenuse, double the short leg. And then if you are looking for the long leg, multiply by the square root of 3 by the short leg. So those are some little equations you can use to help yourself out. So let's look at some problems. So first two examples, you want to find the altitude of the equilateral triangle. So first off, I need to drop an altitude down, and then I want to find the altitude, so I'm looking for x. Okay? Now, if this is an equilateral triangle and this was 60 and I cut it in half, that means this angle measurement is 30 and this angle measurement down here is 60. Okay? So now I can use my 30, 60, 90 triangle to find my missing sides. Now I know the hypotenuse is 8, so to find this short side, I'm going to divide it by 2 to get 4. So always find the short side first. Now to find x, that is across from the square root of a 60, so I need to multiply by square root of a 3. So I would have that x is going to be 4 root 3. And I'm done. So basically, once you find the short side, to find the 60-degree side, you times it by the square root of a 3. To find the hypotenuse, multiply it by 2. Okay? So when the short side is a nice whole number, everything is fantastic in the world. Now, again, I'm going to drop down and find an altitude. Again, this is my 30-degree angle, and this is my 60-degree angle. Now, if I cut that in half, or first off, I know all the sides are 10, and then I know half of 10 is a 5. Okay, so I know my short side is 5. I know my hypotenuse is 10, which double checks out. And then I'm just looking for this x piece right here, my altitude. If I know the short side, which is 5, multiply by square root of 3. So 5 square root of a 3 would be your answer for your altitude. Okay? All right. So let's look at some more challenging problems for 30, 60, 90 triangles. All right, find the missing variable. The first triangle is equilateral. So I know all of these measurements in the corner, 60, which means this measurement up top is 30. Now they weren't nice and they didn't give me the short side. So I need to find this short side first. They did give me that the 60-degree angle had square root of a 3, which is good because to find the short side, I can just ignore that square root of a 3, okay? Because the square root of a 3, when I divide by 3, I just get a 10. So my short side is a 10, all is right in the world, times by 2 to get 20, okay? So the problem is not bad when they give you the 60-degree angle and it has a square root of a 3. All can still be right in the world with that problem. All right, so in this middle problem, they gave me my short side because it's opposite of the 30-degree angle. And okay, so I need to find the hypotenuse and I need to find the longer side. So to find the hypotenuse, I need to times by 2. So 3 squared of 2 times a 2 is just going to be a 6 root 2. So this is going to be 6 root 2. Now to find my longer side, you have to multiply by the square root of a 3. Okay? So I'm going to multiply these two to get 3 root 6. And I can't simplify the square root of 6, so I'm done. Okay? So when you're multiplying numbers, you multiply their like terms. Okay? So if they both have square roots, you multiply them. If they're both whole numbers out front or constants, you'd multiply those. All right. Last problem. 30 angle would be up here. So they did not give me my short side. They gave me the not nice side. And it's not nice because it doesn't have a square root of a 3. So to find the short side, let's look back up here. I want to find the short leg, and I know the long leg. So short leg equals long leg divided by square root of a 3. So my short leg equals that long leg divided by the square root of a 3. Now I'm going to have to rationalize the denominator and multiply by the square root of the 3 over square root of a 3, which would give me a 3 in the denominator. 3 times 15 is 45, so I have 2 root 45. Now I have to break down 45. Gotta simplify 2 root 45. What goes into 45? 9 times 5. With a 2 out front. So square root of a 9 is a 3. So this problem is now 3 times 2 square root of 5, which is 6 root 5. So that now is replaced up here. So I have 6 root 5 over 3. I know 6 divided by 3 is 2. 2 root 5. So yay, I found my small side. So I repeat, these problems are not nice when they give you the 60-degree angle and it is not a root 3. If they give you the 60-degree angle and it's a root 3, you just drop it. Over here, you have to divide by it and rationalize and simplify, and it's a lot of work. Okay? But once you find that small side, you just have to multiply it by 2 to find the hypotenuse, which would be 4 root 5. Okay? So again, 30, 60, 90 triangles are the hardest by far, and they are going to be the hardest when they give you the 60-degree angle with the funky radical. But that is probably not going to happen a lot. Okay? So thank you for watching, and now you get to practice.